Hey guys, it's Mr. Westbrook. Today, we're going to talk about angles and their names, because angles, just like us, have very special and very specific names. So here we go. We have an angle right here, right in front of us, and this angle has its own name. Its name is ABC. But notice how I put B in the middle. B is in the middle because that's the vertex. So when we name an angle, the vertex point, or this corner point right here, that's the point that's in the middle. I could also call this angle CBA, as long as I put the vertex point in the middle. We have different types of angles too, and some of them we've already talked about. There are four main types of angles, and then everything else kind of has subnames that goes with it. So the first angle is a right angle, and it's a 90 degrees, and it makes that L shape. And then we have acute angles, and they're cute because they're teeny tiny and less than 90. And then we have obtuse angles, and those are the angles that are bigger than 90. And then we have straight angles, and those are the angles that make a straight line. Okay, so those are the four main types. But in those types, they have special names. Let's talk first about congruent angles. What does that word congruent mean again? If you said the same, you're right. Congruent means the same. And so when we talk about congruent angles, we're talking about two angles that have the same measure. So way back to when we were talking about rigid transformations, shapes are only congruent if their angles are the same. If their angles aren't the same, then they're different shapes, and they're not congruent. So here we have angle ABC. Notice how I put B in the middle because that's called the vertex. You're right. And we have angle DEF. What do you notice about these two? They're both 30 degrees. So that means if I pick up angle DEF and I translate it, what does translate mean again? If you said slide, you're right. If I pick up angle DEF and I slide it over, look and see how it lines up perfectly? That makes it congruent. And congruent angles have the same shape and size. Very important thing to remember. Now we have this word adjacent angles. And adjacent just means I'm standing next to it, or it's right next to me. In math, we come up with fancy words, but they have simple meanings. Adjacent just means right next to. I'll show you. Two angles that have a common vertex and a common ray are called adjacent angles. So here we have angle ABD and DBC. These are adjacent angles because they share this point right here, B, called a vertex. Now we have vertical angles. And vertical angles are angles that are opposite of each other. Opposite, opposite. Where have I heard the term opposite? That's right, a reflection. Reflections are opposites. So, when we look at these angles, we have angle P right here, or not P, we have the vertex P right here in the middle. That's where they intersect. But if you notice, these two angles in green, they're opposites of each other. They're a reflection. And because they are a reflection, and because reflections are rigid transformations, these angles must be congruent. They must be the same. And they're not the only vertical angles in this picture. These angles in orange, they're also congruent because they're also reflections. Now we have this word complementary angles. And complementary angles, I just want to see if you can guess, just looking at this picture. Right. Complementary angles are angles that add up to 90 degrees. 60 and 30 adds up to equal 90. 90 degrees are also known as right angles. So any two angles that add up to equal 90 degrees, they're called complementary angles. So like 20 and 70, 10 and 80, because they add up to equal 90 degrees, they're complementary angles. Complementary angles add up to 90 degrees. Then we have supplementary angles. Supplementary angles and complementary angles are not the same thing. Supplementary angles add up to 180 degrees. What does a 180 degree angle look like again? That's right, it's a straight line. So when I look at two angles that add up to 180 degrees, they're supplementary angles because they would make a straight line. Okay. Now we have this fancy word called a transversal, but let me show you a picture. A transversal is a line that intersects two or more lines at different points. So here we have two lines, and these two lines are very, very special. These two lines are called parallel lines. What are parallel lines? What is special about parallel lines? If you said parallel lines never get further apart, they never get closer together, you're right. So when I like to think of parallel lines, I think of train tracks, or the tile on my floor, or those double yellow lines on the road. Those are all parallel lines. They never get further apart, they never get closer together, and because they don't, they'll never ever cross. So now we have this line, GF, and that's the transversal, because it cut across these two lines in red. So the yellow line is the transversal. Let's talk corresponding angles. Corresponding angles are angles that show up when we have transversals. So corresponding angles are angles that are in the same spot in both lines. And it's better to see it in a picture. Corresponding angles are also congruent. But why? So here we have our transversal. Remember, transversal, two parallel lines and a line that crosses it. And we're going to have all these angles. I'm going to move myself down here so you can see. So we have angle GPB, and angle PQE. I want to highlight those in pink so we can see them. Okay. These angles are corresponding angles. What do these angles also look like? A translation. If you picked this angle up, you could translate it down to here. And translations are congruent. These angles are congruent. And the reason we know they're congruent is because we could translate this. But there's an easier way to look at it. These angles are in the same spot. So look, they're both on the right-hand side. And they're both above their line. So corresponding angles are angles that are in the same spot in both lines. Well, let's look at some other ones, because there's more than one pair here. We have the two green angles. They're both on the left-hand side of the line and above, and they're also corresponding angles because I could translate. And we have the two orange angles. They're both in the same spot below their line and on the right-hand side, and I could translate. And then we have these other two green angles with the blue. They're both in the same spot below their lines on the left-hand side, and I could translate. So corresponding angles, angles that are in the same spot in both lines, and they are congruent, which means they are the same. Now we have this other term called alternate interior angles. And when I think of the word interior, I want you to look. See right here? Inside. When you think of alternate interior angles, I want you to think of the word inside. So, here's my transversal. Remember, two lines and a line that crosses it. And inside, I have alternate interior lines. So, I have line B, P, Q, and D, Q, P. And I'm going to highlight them in orange so you can, or in pink so you can see it. These angles are congruent. What kind of rigid transformation do you think this looks like? I said a rotation because it looks like I could spin this angle here and I could spin it all the way to this angle here. And because I could spin it, that means it is congruent. Alternate interior angles are congruent. They're not the only pair though. We have angle APQ, and we have angle EQP, EQP. And they also look like a rotation. And they're also considered alternate because they're on opposite sides, interior because they're on the inside angles. And they're also congruent. Alternate interior angles are congruent.